This is part 3 of the Deluxe Tweed build. We're going to start working on the chassis and mounting all the components and doing all the wiring. This box is from Antique Electronics Supply, which is where I usually get most of my stuff. And they have just about everything for building new amps or old amps or however, whatever style you want to do. They also have components for radios and lots of other stuff. I'm not going to go through a whole dumbass unboxing. You know, I've seen so many videos where I go, we're going to unbox the new bullshit. We're not going to do that. So anyway, I'm going to start mounting all the components to the chassis. I bought a pre-made chassis for this build because the original Tweed Deluxe had a chrome-plated chassis. And to get anything chrome-plated these days is ridiculously expensive, so it was just cheaper to buy the chassis already made. It's pretty much identical to the original Deluxe, with one exception. The ground switch that was on all the early Fenders has been replaced on these because nobody uses those. They're not really safe. Drilling the eyelet board with the CNC router. No way I'm doing that by hand. I'm gonna speed through this part. It's kind of boring. You know, I say it's boring, but when you have to go into everything that has to go into setting up this program, setting up the machine and all that, it's not really boring to me, but to watch it on YouTube video, it's boring. After you drill out the eyelet board, you just put the eyelets in, turn it over, and use this little tool that I made and flare it out, and that's what holds them in place. It's pretty simple. Takes a little time, but it's not that bad. It goes pretty quickly. This part is time-consuming and tedious, so I'm not going to show installing every single little component. I do a fair amount of soldering on this eyelet board when it's out of the chassis. It's easier to do. I can go ahead and poke wires through and leave them long and do all the soldering, and then flip it over and clip them off short, so I don't have to work down inside that chassis. It's not a very big chassis. Rob Robinette's website has a lot of good information on building this Deluxe Tweed, and I recommend using his website for you can download his schematic and his layout, and it's really well done stuff and easy to follow. So I recommend it. I'll put a link in the description. If that works now, I don't know. Supposedly my links will work now, but you know, who knows? It's YouTube. The white cube-shaped item on the end of the board is the cathode resistor. And right next to that is the bypass capacitor for the power tubes. And it's a 5-watt resistor is why it looks so much different than the other ones on there, because it has to be able to handle the current for those output tubes. There I'm putting in some of the dropping resistors for the different nodes in the power supply. All of the leads you see hanging off the board attached to different components in the chassis. You can see I skipped some stuff. The board's in the chassis and wired in. This part that I'm getting ready to show you is how I have a procedure that I go through when I turn an amplifier on like this for the first time. And I didn't get to show it on the previous build, but this is a subsequent build. It's the exact same chassis, everything's exactly the same. But the procedure is what I kind of wanted to go through here. So the first thing I do is I have a current limiter that I plug into, and I set up my meter. And what I want to do without the tubes, none of the tubes are in place. I just turn the power on, and I'm going to check the AC voltages. We have 3 different voltages that we have to check to make sure they're correct. So I'm going to test the filament voltages first. This is for the rectifier tube, and it should read 5 volts or a little more. And then this one will be for the other 4 tubes, which have a 6.3 volt filament, and it's probably going to read a little high. Like I said, there's no load on anything, so they're going to read a little high right now. So we're going to check all the way down the line. There's the pilot light, same thing. And we'll go to the next power tube and then down to the preamp tubes and check the voltages there. And those also read out approximately 7 volts, which is what I want to see right now. This whole time I'm testing, I'm plugged into a current limiter, so if there's any shorts or anything like that, it's not going to do any damage. Now I'm going to check out the secondary voltage on the transformer. I shouldn't be doing it this way. It's not a good idea. I should be using my clip-on ground lead and only having one hand anywhere near that chassis. Because, as you just saw there, we've got 370 volts going into the rectifier tube. So yeah, you can get hurt. So the next thing I'm going to do is I'm going to plug in the rectifier tube and start checking my high voltage DC, or what's called the B+. So now I'm going to use the clip-on lead and connect it to the chassis, and then I can just use one hand. Now the reason for that is that we're going to be looking at voltages up around 500 volts. And if you've got 2 hands in that chassis, that voltage goes right through your heart. In one hand, out the other. And if it doesn't kill you, it'll sure as hell light your ass up. So, okay, we're going to test it here. And as you can see, we've got about 494 volts. My other hand is in my lap, where it's going to stay for now. So I'm going to switch off the power, and then I'm going to go ahead and plug in the rest of the tubes. And I'll leave it connected to the current limiter, but when I test for bias, when I bias the output tubes, you can't be on the current limiter because it'll give you a false reading. For the next part, I'm going to need 3 meters. We're going to plug the output tubes in through what's called a bias probe. That way I can read out directly what the plate current is. So I'll have a meter on each output tube, and then I'll have another meter that's going to be on the checking the plate voltage between the plate and the cathode, which gives you the correct voltage for making the calculation to determine what the actual plate dissipation is. Now, I'm not going to go into a long-winded discussion of tube bias theory, but what you want to do is you want to get that output tube in their safe operating area. A 6V6 like these, the 6V6 GT, has a maximum plate dissipation of 14 watts. In a single-ended amplifier, you can run it right up to 14 watts. In a push-pull like this is going to be, you want about 70 to 75% of that. Too far below 75%, you're going to get early distortion, and too high, and you're going to wear out your tubes. Okay, we're back to the original 5E3. That last segment was a different 5E3 amplifier, but I hadn't shown the way I test all the voltages on this one, so I used that one for that. But they're identical, so it's pretty much the same. So you can see here that I've got my 3 meters set up. The one on the left is going to be plate to cathode voltage. The other 2 will be the other 6V6s, one on the left and one on the right. So you can see here I've got 392, roughly 390 volts on the plate to cathode, and roughly 41, let's call it 42 milliamps on the plates. I can tell you already that's too much. That's too high. So I did the quick math on it, and you'll see that it's biased too high right now. So it's plate to cathode voltage. And then you multiply that times the actual amps, not the milliamps. So you have to add that 0. And that's 16 watts of dissipation. That tube is designed for 14. So that's just too much. That tube would burn out in no time. Wouldn't last very long. So we have to change out the cathode resistor and to a higher value. So I'm going to go ahead and pull out that resistor, and I did a few more checks with some different values and finally came across this one, which seems to give me the answers I needed. So we ended up with about 25 milliamps. So we multiply 0.025 times the plate voltage, which I believe was 416, and that gives me 10.4. That's perfect. It's about 75%, which is right in the ballpark. Those wire wound power resistors don't come in very fine increments, so this came in just right. So we're happy with this. So this is the finished amp. I got a little smudge in that upper left corner that I must have put on when I was actually trying to push that tweed into place, and got some dirt off my thumb or something, but I can't get rid of it. Oh well, hey, it gives it character. Anyway, that's the back, and we'll take a look at the control panel here in a second. That is a Fender. That's actually a Jensen speaker. And there's the control panel. Pretty much the same as it was back in '57 or so, but except that it has a standby switch where it used to have the ground switch. So I'll do a sound demo, and I'll be using these two guitars, and the amp is sitting in the back with the SM57. This is a guitar that I built, and I'll be using that for parts of it. And most of it I'll be using this Les Paul that I bought back in 1972. Now don't blame the amp on the rather amateurish guitar playing you're going to hear. I'm sure if you handed this gear over to Billy Gibbons, it would sound just fine. Maybe even better. All I did here is add a little reverb to the guitar. Otherwise, it's just raw guitar and amp into an SM57. It is what it is. So that was it. Thanks for watching.